Water scarcity is becoming a major topic in the world and has been a major topic for quite a few years. However, we're getting to the point now where the population demand for fresh water is so high that it is actually outstripped the freshwater supply that we have. This has caused major issues around the world, especially in built-up areas that face water scarcity, that face issues with getting fresh water, or that face issues with distribution of fresh water. One of the solutions for water scarcity is desalination. Of course, 70% of the world's surface is seawater, so we do have an enormous amount of water available to us, just not of drinkable quality. So the question is desalination then a solution to reduce the water scarcity and to supply populations with fresh, drinkable quality water? And that's a question that's been asked for many years, and there are issues associated with that, of course. With desalination, it's costly. Firstly, it's a lot cheaper just to take water out of a river or out of a dam or from an aquifer. And desalination also demands a huge amount of energy. And in the past, it was enormous amount of energy. And now with reverse osmosis, it becomes just a huge amount of energy. And of course, energy is costly, which comes back to the cost issue. The other issues with desalination is, of course, you have to have access to the seawater. You have to protect the marine life. And then the desalination, in the process, they normally add chemicals and minerals to the water, and then those chemicals and minerals go back out into the ocean with the brine that is produced. And that's also one of the key issues that faces desalination today, is that a very large amount of brine is produced. And that brine is essentially concentrated salts, and that gets, at this stage of the game, dumped back into the sea. Desalination has come a long way in the last 20 years, or even in the last 10 years. Originally having evaporation and evaporating water with very low recoveries, and then putting the brine back into the sea was costly and pumped a lot of CO2 into the air. But since the invention of reverse osmosis, this has decreased the energy dramatically. So it decreased the amount of CO2 that goes into the air, improved the recovery rates such that you get higher recoveries, meaning less seawater comes out of the sea. And all of that has led to a large decrease in the cost of desalination. What was $1 per meter cubed is now sitting at $0.50 per meter cubed of water, or even less in some cases. So all of these issues have really helped desalination in the last 5 years or so, and we start to see it becoming, from a cost perspective, a really viable solution. The advent of renewable energy through solar and wind has also reduced the costs dramatically. Because renewable energy has come down in costs to a large extent, connecting that up with a desalination facility enables us to further reduce the costs, but more importantly, this has enabled us to reduce the CO2 that's put into the air. So connecting up renewable energy with reverse osmosis from a cost and an environmental perspective has become very interesting for the world. And now it's something that certainly the world can look at and say, this may be the solution. We are still left with the brine issue. Concentrating seawater, adding chemicals to prevent the membranes from being damaged and from clogging up. These issues still exist because those chemicals and minerals go back into the sea and then alter the sea life or alter the marine environment. So one of the solutions to that is not to put the brine back into the sea. Or if you are going to put the brine back into the sea, put it back into the sea such that it's in a better condition than what you took it out of the sea. Some of the areas in the world have really advanced with desalination. For example, the Middle East and Australia. Australia, a lot of the desalination in Australia is done offset by renewable energy. So they've solved the first two issues, and one of them being cost, and the other one being the CO2 that goes into the air. So many of the Australia facilities are based around renewable energy, and we see the same happening in the Middle East, in Saudi Arabia, in the United Arab Emirates. These desalination plants are now being connected up to solar facilities or being offset with renewable energy. I mean, the benefit you have is normally where you don't have water, you have a lot of sun and wind, and you can put in solar energy systems that generates a lot of power. What we are doing in NEOM is what we call zero liquid discharge. It's not because we don't want to put anything back into the sea, but it's because we have a very sensitive marine environment. We have some of the best coral reefs in the world along the NEOM coastline. So we're not allowed to put the brine back into the sea. So we have to go all the way to zero liquid discharge. And then what we are doing then, because we're doing everything with renewable energy, we're solving all of the issues around desalination. Not only that, the fact that we then are solidifying the CO2 that is actually inside the seawater by making products out of it, we're actually reducing the amount of CO2 rather than increasing the amount of CO2 through our desalination processes, and creating really usable products through the brine mining that we're doing, through creating gypsum, magnesium, potassium, chemicals and minerals, as well as salt. And this enables us to create products inside, and that reduces the amount of transportation we use for actually buying those products from elsewhere. So all in all, you can see that desalination is really going in a strong direction towards it will be beneficial for the world. And given that 70% of the world is seawater, it suddenly will take water scarcity completely away, especially from those people that are living near the coastline.